So these are some additional examples from section 2.2 part 2. In this first example, we want to find the equation of the tangent line to f of x equals to the square root of x plus 4 at x equals to 5. So to find the equation of a tangent line, that's the equation of a line, we need a point and we need a slope. So we're given the x coordinate that describes the location of where we want to find the tangent line to on the curve, but we want to find the actual point. So we need the y coordinate that goes with that x coordinate. And we can find that from substituting 5 into the function. Okay, so we would get y equals to 3. So the point on the curve that we're trying to find the equation of the tangent line to would be 5, 3. So we have our point and we still need our slope. We will find the slope of the tangent line from the derivative, evaluating the derivative at x equals to 5. So first let's find the derivative of f of x, which that will be f prime equals to the limit as h approaches 0 of the difference quotient, which in this case would be x plus h plus 4 minus the square root of x plus 4 all over h. We know we're going to need to try and get that h in the denominator to cancel, and we'll use our RATCON strategy. So we will try and rationalize the numerator by multiplying by its conjugate, which will be the square root of x plus h plus 4 plus the square root of x plus 4 over itself. If you need to, draw parentheses, like draw the grouping symbols around the numerator and denominator just to remind you that the division bar is a grouping symbol. When we multiply the numerator out, we'll get, I won't need the parentheses anymore, we'll get x plus h plus 4, and then minus the quantity x plus 4. The denominator, I'm going to leave that h factored out. Do not distribute the h because we're trying to get it to cancel. And then I can distribute that negative. So I have the limit as h approaches 0 of x plus h plus 4 minus x minus 4. Denominator is still the same. And now the fun part, let's look at what cancels. So the x's cancel, the 4's the 4's cancel. And then if you notice, we just are left with an h in the numerator, which that h will cancel with the h in the denominator, leaving us with the limit as h approaches 0 of 1 over the square root of x plus h plus 4 plus the square root of x plus 4. Now that we got that h in the denominator to cancel, let's try direct substitution for evaluating the limit. And that will end up simplifying to 1 over 2 times the square root of x plus 4. So that's our derivative. And we can now use our derivative to find the slope of the tangent line. So we're going to evaluate f prime at 5. Which that will end up giving us 1/6. So the equation of the tangent line at the point 5, 3, I have my point, my slope, so I'm going to write the equation in point slope form. It'll be y minus 3 equals to 1/6 times the quantity x minus 5. And then I'm done. So here is the equation of the tangent line to the point 5, 3. And let's just look at graphically what that will look like. So we can say the slope of the curve, so the slope of f of x at x equals to 5 is going to be 1/6. So if I type in y equals to the square root of x plus 4, and then y Desmos will let me type this in point slope form, which is kind of cool. I'm going to put 1/6 in parentheses. I don't know if I really needed to or if Desmos would have done it, but just to be safe. Times the quantity x minus 5. Okay, so we have in red is the square root of x plus 4, and then the blue is the line. So at x equals to 5, notice if we zoom in, doesn't it look like, all we see is the blue. It looks like the graphs just end up merging together. So that's why we can say that the slope of the tangent line at that point is equal to the slope of the curve at that point. So the instantaneous rate of change for this function at x equals to 5 would be 1/6. Okay, so let's look at example 2. So find the points on the graph of g of x equals to x cubed minus 12x that have horizontal tangent lines. Well, think about a horizontal line, what a horizontal line is, and what the slope of a horizontal line is. So derivatives, remember, give us, if we evaluate a derivative, it gives us the slope of a tangent line at a point. Well, horizontal lines have a slope of 0. So if we were to set our derivative equal to 0, we could solve for the x values on the graph of g of x that would have horizontal tangent lines. So let's first find our derivative. And we're using our limit definition here for all of these. Oh boy, this is a cubic. So x plus h cubed minus 12 times x plus h, and then minus the original function, so x cubed minus 12x, all over h. And all we can do to try and get that h in the denominator to cancel is multiply everything out in the numerator, so sledgehammer method. And this is going to be a bit of a doozy since we don't have binomial theorem to help us with multiplying. But remember, x plus h cubed is x plus h times x plus h times x plus h, which is also x plus h times x plus h squared. So if I multiply out x plus h times x plus h, I know I'll get x squared plus 2xh plus h squared. And then when I distribute that negative 12, I'll get minus 12x minus 12h. And distribute the negative, that'll be minus x cubed plus 12x all over h. And then I still need to finish multiplying out that first product. Okay, so that'll give me x cubed plus 2x squared times h plus x times h squared plus h times x squared plus 2x h squared plus h cubed, and then minus 12x minus 12h minus x cubed plus 12x. That was a lot. All over h. So here's the fun part. Let's look at what cancels. X cubes cancel. 12x and 12x cancel. Is that all that cancels? I believe that is all that cancels. we have like terms. So these are like terms. And then these are like terms. So I'm going to combine like terms now in the numerator. So that's going to be three x squared times h, sorry, just trying to keep everything straight, plus 3x times h squared. And then we still have the plus h cubed minus 12h. Holy moly, all over h. And we can factor an h out of the numerator. So now that h cancels with the h in the denominator, leaving us with the limit as h approaches 0, 3x squared plus 3x times h plus h squared minus 12. And now we can use direct substitution. And that just ends up being 3x squared minus 12. Yes, I agree with that. So 3x squared minus 12 is our derivative. Now remember, we would find the slope of a tangent line to the curve by evaluating our derivative at different x values. Instead, this question is asking us to locate all of the horizontal tangent lines to this curve. We know that horizontal lines have a slope equal to 0. So we're going to set our derivative equal to 0 and solve for the values that would make that true. So the GCF here is 3. And then that's a difference of 2 squared, so x minus 2 times x plus 2. So x equals to 2, or x equals to negative 2. So those are going to be the two x coordinates where the graph has horizontal tangent lines. But the question is asking for the points on the graph. So let's find the y coordinates that go with those two x coordinates. So let's find g of 2 and g of negative 2. So 2 cubed minus 12 times 2 gives us 8 minus 24, which is negative 16. And then negative 2 cubed minus 12 times negative 2, so that'll be negative 8 plus 24 equals to positive 16. So the points where there's horizontal tangent lines are going to be 2 comma negative 16 and negative 2 comma 16. Let's just confirm that with Desmos. So let's graph y equals 2x cubed minus 12x. Okay, so it looks like here there's going to be a horizontal tangent line, and we can see that's at negative 216, the very top of that hill in the graph. And then down here If we zoom in, we can see that is 2 comma negative 16. So the bottom of that hill, there would be a horizontal tangent line. Okay, so let's look at the last example I have on here. It's a word problem. So Mr. Kim is teaching his physics class about projectile motion by throwing his Superman action figure upward with an initial velocity of 80 feet per second off the balcony of the gym, which is 40 feet above the ground. The height of Superman is a function of time and is described by h of t equals to negative 16t squared plus 80t plus 40. So for this function, if I plug in values for time, for t, it'll give me the height at that moment of Superman at that moment in time. So he's being launched off of the balcony of the gym. So if we draw that balcony, we have Mr. Kim, and he throws Superman. Superman's going to go up, 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 and then down, down, down until it hits the ground. So you can see his path would be like the quadratic, negatives h of t equals negative 16t squared plus 80t plus 40. All right, so let's find the derivative of h of t. So that's going to be h prime of t. And we're taking the limit as h approaches 0 of our difference quotient, which will be negative 16 times t plus h squared. Notice I'm just using t's instead of x's, plus 80 times t plus h plus 40, and then minus h of t. All right, we need to use sledgehammer here to multiply everything out in the numerator. So t plus h times t plus h is going to be t squared plus 2t times h plus h squared. Distribute that 80 in. And the negative. And then also distribute the negative 16. Look at what cancels. And we should be left with only terms that have an h in them. And since I'm left with only terms that have an h, I can factor an h out of the numerator. So that now we get the h in the denominator to cancel with that h in the numerator. This keeps freezing. And then now let's use direct substitution. So we get negative 32t plus 80. That's h prime. What does the function h prime of t model? So the derivative of the function, this is a position function, meaning when we plug in values for t, so when we plug in values for time, it tells us the height of Superman off of the balcony. if we wanted to determine how fast Superman was traveling at any moment in time, like we wanted to calculate his instantaneous velocity, so the velocity of Superman at any moment, then we're going to need to use the derivative. So the function h prime of t, which is equal to negative 32t plus 80, t still represents time, but h prime of t represents Superman's velocity. So h prime of t represents Superman's velocity as a function of time. And the units for velocity in this case, the height is being measured in feet and time is being measured in seconds. So velocity will be in feet per second. So when we want to determine Superman's velocity at 2 seconds, we're just going to plug 2 into h prime. And we'll get positive 16. The units are feet per second. So that means at 2 seconds, Superman is moving at a velocity of 16 feet per second. We can also say, so in other words, you could say like Superman's height, or Superman, how about Superman is like traveling through the air. I'm not going to write another. So Superman's like traveling through the air at a rate of 16 feet per second. Because we end up with a positive velocity, a positive value, that tells us that Superman's height is going to be increasing at 2 seconds. So like we would predict from going from 2 to 3 seconds that Superman's height would increase an additional 16 feet. So he's still on his upward in the picture, he's still going up at 2 seconds. And then part D, what is Superman's velocity at 4 seconds? So let's evaluate h prime at 4. And we should get negative 48 feet per second. Because we end up with a negative velocity, that tells us that Superman's height's going to be decreasing at that moment in time, meaning that Superman has is on his descent towards the ground. Sonia, I'll come find you in a sec. So we can say at 4 seconds, Superman is moving at a velocity of 48 feet per second. But if to show the direction, we can say Superman is moving towards the ground at a rate or a velocity of 48 feet per second. For this one up here, for part C, we should have implied direction. Like we could have said that he is moving or like traveling into the air, something to indicate direction, because velocity has both magnitude and direction. His speed would be at 2 seconds, 16 feet per second, and his speed at 4 seconds would be 48 feet per second, but velocity has to also have direction in there. When will Superman reach his maximum height in the air? Okay, so let's think about this from our picture. So Superman goes up, 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 and then goes down, down, down. So what's going to happen before he starts traveling down? He's going to end up kind of hanging in the air for a second, meaning his velocity would be 0 feet per second at his maximum height, because he's going to travel up, 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 hang there for a sec, and then come down, down, down. So we want, in order to determine when Superman will reach his maximum height from a calculus perspective, because you could do this from an algebra perspective just by finding the vertex. But for determining from a calculus perspective when Superman would reach his maximum height, you're going to set the derivative equal to 0. And then solve for t. So 80 divided by 32 is going to be 2.5. And the units on t are seconds. So Superman will reach his maximum height at 2.5 seconds. I'll come over there in a second and finish this one. So Superman will reach his maximum height at 2.5 seconds, and we found that from solving for the time at which his velocity would be 0. All right, so for how long will Superman's height be increasing, and how long will his height be decreasing? So if we go back to our picture, okay, his height will be increasing on the rise here, and then it'll be decreasing as he's traveling towards the ground. So we know from 0 to 2.5 seconds, when he reaches that maximum height, that his height will be increasing. So Superman's height will be increasing between 0 and 2.5 seconds. And then after 2.5 seconds, his height will start decreasing, but he's not going to just continue dropping and dropping and dropping. We want to figure out when he will hit the ground. So we can actually go back to our original equation. So our function for where our outputs were height as a function of time. And let's solve for the values, or for what times Superman's height would be 0, meaning he would be back on the ground. So let's set that original equation equal, what is it, plus 80t plus 40. So we want to solve this equation. And we can do that by using the quadratic formula. So 80 squared will be 6,400 minus 4 times A times C all over 2A. Okay, so that'll be the square root of 8,960 divided by negative 32. So when I type that into my calculator, I get t is approximately negative 0.46, which doesn't make sense as a time, or t is equal to 5.46 seconds. So Superman's height will be decreasing between 2.5 and 5.46 seconds. Miss Greenberg just walked in and is laughing at me.
You're so smart.
.5 and 5.46 seconds.